Good morning, class. Sorry that I couldn't be with you today. The best I could come up with is a video explanation. So what I'd like to do is to have you have an experience today, you with your classmates, that will show you that understanding can come to something that maybe you have never had an understanding of before. What I'm talking about is, you guessed it, division of fractions. We were all taught, I can almost guarantee every one of us were taught that to divide fractions, you simply take the divisor, you flip it upside down, and then you take the dividend and multiply by that flipped divisor. And many of you have mastered that and do a great job performing that. But if we were to ask you why that happens, you probably would not be able to do so very well. What I'm going to share with you today is, work through a curriculum that is actually was written for 6th graders. It's being used around the country in both 5th and 6th grades, and very effectively. And that is, in doing it, you will come to understand why it is we do what we do when we're dividing by fractions. Some of you may have even asked your teacher, why do we do it this way? And your teacher may have responded, yours is not to question why, just invert and multiply. Anyway, what I'd like you to do is turn the video off right now, and what I'd like you to do is read page 77 and 78 of the handout, and then read problem 7.1. When you've read the problem and get down to number 1, go ahead and turn the video back on. Okay, so turn it off right now, read those 2 pages in the beginning of that problem. Welcome back. You understand the problem, and what I'd like to do is, I would like you to look at it through the eyes of a 5th or 6th grade student. I know that's going to be hard for some of you because it's been a while, and some of you don't even remember being a 5th grader or 6th grader, but I think we can do that. I think that's possible. So if you'll notice, the problem says that there are 9 packages of cheese. And if I have 9 packages of cheese, and I'm going to use those packages to make pizza, how many pizzas could I make if I needed 1/3 of a package of cheese for each pizza? Well, you don't need to know any magic tricks. All you need to do is know how to think about fractions and say, well, if it takes 1/3 of a package to make a pizza, I could cut this package into 3 parts, this one into 3, this one into 3, each of them cut into 3 parts, and that would represent 1/3 of a package. Then I could use this 1/3 of a package to make my first pizza, this one for my second, third, fourth, 5th, 6 pizzas with 2 packages, 7, 8, 9 pizzas, 10, 11, 12, 13, 14. I could make 15, 16, 17, 18 pizzas, 19, 20, 21, 22, 23, 24, 25, 26, 27. And I think any 5th grader who has an understanding of what a fraction is, 1/3, cutting something into 3 equal parts, could do that. So the answer to my question is how many pizzas could I make with the 9 packages? If each pizza takes 1/3 of a pizza, I can make 27 pizzas. Now, the directions say that you're supposed to write a number sentence to represent what we did. Well, what we did is we took 9 pieces of pizza and we wanted to know how many third packages there were in there. That's a division problem. And I think most students that have learned with understanding in 5th and 6th graders would know that that's how many 1/3 there are in 9. Just like 12 divided by 4 means how many 4s are there in 12. But that's not what we did. What we ended up doing was we ended up taking the 9 pizzas, cutting them each into 3, and for each pizza there are 3, so that's 9 times 3. And we got 27. So here's the thinking we did. Here's our answer. But here is the situation. How many 1/3 are there in 9? Okay. Turn the video off. Finish all of 7.1 and any of the associated follow-up. No, let's do this. Let's do the 4th problem. Let's do the 4th problem.